Everyone, and this is just I'm trying to developing something about the website. You just try to copy the link here, solutionexaminatio.wixsite.com website. And yeah, that's name is a bit weird for the name of a website, but I'm just trying for it. Okay, so this is just the interface of what the website content is. Examination solution, right? And right, the videos are constantly being updated, and this is the solution I have covered. Okay, about Gakubu Math, Gakubu Chemistry, Gakubu Physics, and this will be coming soon. Kosan Chemistry and Senshu, right? And yep, I think maybe I could touch in content with the A levels and everything. And if you want to suggest what kind of content that I should make, and you just can make your submission here for the email, or you can actually directly contacted me at the Gmail. And for the Instagram uh, account, it has actually already been created, but I will develop it soon. Okay, so yeah, stay tuned for the next update.
Hello everyone, welcome to this Monbukagakusho Mathematics 2014 for part 1, number 4. Now you can see that there's a question about logarithm. This is the logarithm inequality. So you can see there the logarithm with base 2 of x plus logarithm of base 2 of x minus 2 is less than 4 times logarithm with base 16 of 8. Now for the sake of just this video to ease your calculation, I will make that logarithm with base 2 of x. I just move the base 2 up, so this way. So I'm pretty used to do this type of logarithm this way, so it just didn't matter. Okay, so 2 base 2, right, logarithm x plus base 2 logarithm of x minus 2 less than 4 times 16 logarithm of 8. Okay, so how to calculate this? First is that you have to make the base equal to each other. Okay, so this is just the same. Now 16 is 2 to the power of 4, right? Logarithm of 2 to the power of 3. So you can put that in the front, because you know that the one of the identity of the logarithm is that if you have a with the power of m as the base, logarithm of b to the power of n, this is equal to n over m base a logarithm b. So if we actually uh, apply that, there is 3 to the power of 4, and the 2 logarithm of 2 is 1. Okay, remember another identity of the logarithm, a logarithm a is 1, whatever it is. If this is the same between base and the content of the logarithm is equals to 1, right? So, and then another identity of the logarithm is that when you actually add the logarithm with the same base, remember, with the same base, a and a here, for example, and 2 here, this is equal to a logarithm b times c. Okay, you can actually do that here. Multiply that, x times x minus 2, and this is, you cancel it, 3. Remember, for this inequality, I said that we should equal the base. We change it into logarithm form. That is 2 logarithm 8, right? Because 8 is 2 to the power of 3. That is basically equals to 3. Okay, and now this form we can actually now apply the inequality method. Okay, you can see there x times x minus 2 over 8. Because this is have the same base, you can just make it this way. Okay, you try to find the answer here. All right, this is the way you do it. And now you have to factorize this. X plus 2, x minus 4. So you can get this inequality. So this is just, x plus 2 equals 0, x equals minus 2, then x minus 4 equals 0, x equals 4. And remember, if you have less than, minus 2 and 4, you make it this way. If you have greater, you make x less than minus 2 and x greater than 4. So this is the big difference between less and greater than. But remember that in this logarithm question, it is not finished, because you can see that in this interval, you can actually apply minus 1 into this initial logarithm. But you know that logarithm of minus 1 is, math error. There is no such a thing of negative logarithm. And even you can actually apply 0, right? From this interval, you can apply 0. Logarithm 0 is nothing, math error, right? So this interval is not yet finished. So this is, we could actually apply one more thing. Because logarithm, logarithm thing, it should be greater than 0. Okay, it cannot be 0, it cannot less than 0, it should be greater than 0. So the variable here, x and x minus 2, each of it, we make that greater than 0. Okay, so x greater than 0 and x minus 2 greater than 0. X is x greater than 2. Now we have 3 intervals. We need to find the real interval. Just make a number line. You can see that between minus 2 and 4. Okay, make it that way. Then x is greater than 0 is this way, right? Then x greater than 2. You can see the one with the most line here is 2 less than x less than 4. So that is the real interval of the answer to number 4. And you can see there that for this type of interval, you must make sure that every number inside this interval is sufficient and is able to actually satisfy this equation. Okay, you might wonder where it is correct. You can see here at the answer key, look at that, mathematics B number 4, part 1 number 4 is 2 and 4. Okay, so basically in this logarithm, beware of the logarithm inequality which has a variable in its content. Okay, you must make it greater than 0 automatically after you find the content of it, and you can make it greater than 0. Okay, so the answer for part 1 number 4 is 2 less than x less than 4. Okay, and stay tuned for another part, and thank you for watching.